Hey there, we're going to talk about the three forms of the quadratic function, and we're going to see this interactively through Desmos. So here I have the three different forms of a quadratic function: the general form, the intercept form, and the vertex form. Let's go and understand this interactively. I'm going to start with the very first one, the general form of a quadratic equation. Um, the general form of a quadratic equation is the most popular one, and it goes as ax squared plus bx plus c. I'm going to add sliders for a, b, and c so I can show you interactively what happens when I vary the values of a, b, and c. So the equation that's right now in front of us is 1x squared plus 1x plus 1 because I've chosen the values for a, b, and c as 1 each respectively, right? You know that every quadratic function is a parabola of one form or the other, right? And this equation 1x squared plus 1x plus 1, it looks like this. Now let's vary the levels of a, b, and c to understand their role in the quadratic function. Let's start with c. I'm going to increase the value of c from 1 to 2, 3, 4, and so on. And you'll observe that the parabola is shifting upwards. Now I'm reducing the value and the parabola is shifting downwards. There is no change in the shape of the parabola, but it is simply shifting up or down. Now, if you observe closely, what you'll see is that the value of c is the point on the y-axis at which this parabola is intersecting with the y-axis. In other words, the value of c is the y-intercept of this parabola. So let's make the equation something else. Let's say the equation is x squared minus 6x plus 5. And so this is how my parabola is going to look. Let me zoom out so you can see the entire thing. So this is how my parabola looks when it is 1x squared minus 6x plus 5. And you notice that the parabola is intersecting with the y-axis at the point 0, 5, right? And so C is the y-intercept of the parabola. Let's look at the effect of B. Now, you'll notice that as I increase the value of b and then keep doing that, you'll see that the parabola is shifting. You see that? The parabola is shifting either to the right-hand side or to the left-hand side. So that is the effect of b. I'm going to put this back at 1, 1, and 1, the original values that I started with, right? So as I increase and decrease the value of b, you'll notice that the parabola is essentially shifting to the right or to the left. I'm going to leave this back at the value b is equal to 1. Let's now look at the effect of a. Now, as I increase the value of a, you'll notice that the parabola is becoming narrower and narrower, right? You see that? And as I reduce it, it becomes broader and more open, wider, wider, wider. And at one point, when I make it 0, so let me make it 0, you'll see that it's no longer a parabola. Well, in fact, it is a straight line. When I decrease a below 0, you'll notice that the parabola is now downward looking or downward open. It's a sad face, right? And as I decrease it further, you see it getting narrower and narrower. So that is the effect of a on the quadratic function, right? So when a is a positive, it's a happy phase, it's an upward open parabola. And as I increase its value, it gets narrower. And the same thing happens on the negative side. As I make it lower and lower, or a higher negative number, the parabola gets narrower and narrower. I'm going to leave this back at the original value that we started with, which is equal to 1. Now that is the effect of the three terms a, b, and c on the quadratic function, right? I'm going to now make the value something else. I'm going to say it is x squared minus 6x plus 5. So this is our equation. Now, if you notice here, this parabola has two x-intercepts. They are the points 1, 0, that's where I'm hovering the mouse, you can see it, and the point 5, 0. These two are also called the roots of the quadratic equation, right? These are the 2 points where the parabola meets the x-axis. Now, what is the significance of this? Now, to understand the significance of this, let's link this with the second form of the quadratic function, which is the intercept form of the quadratic function. So I'm going to go ahead and add the expression for the intercept form, and that is essentially a times x minus p multiplied by x minus q. I'm going to add the sliders for P and Q. I'm going to choose the values of P and Q as, let's say, 1 and 5. There's a reason I'm doing this, and you'll see this in a bit, okay? I'm also going to change the color of this. I don't want this to be red, so I'm going to make this, let's say, blue, okay? Now, notice that these two are essentially the same. Well, if I change the values of P and Q, you'll see what I'm talking about, right? You see, now there are two parabolas. As I make the value of P equal to 1 and the value of Q equal to 5, the blue and the red parabolas are essentially the same. Now that is the intercept form of the quadratic function. So the intercept form of the quadratic function talks about the 2 points where the parabola is touching the x-axis. So P and Q are those 2 points where the parabola cuts the x-axis. Now, by the way, you want to remember that not every parabola might cut through the x-axis. There might be some that do, there might be others that don't, but we're not going to get into that for now, right? Now, the one other connection that I want to talk about, these two, the vertex form, or rather the intercept form and the general form of the quadratic function, is to use the quadratic formula. This is something that you might have come across, but I'm going to put the formula that's minus b plus or minus. I'm going to start with plus square root of, so here is my square root function, b square minus 4ac the whole divided by 2a, right? As I do that, you'll notice that there is a value here that says is equal to 5. That is the value of one of the roots. This time, let's do the second root, but I'm going to change this plus to minus, because remember, we have two roots, minus b plus or minus square root of b square minus 4ac, the whole divided by 2a. And you'll notice this time that I have the value 1. The 5 and the 1 are the two intercepts of the parabola, as we saw in the intercept form. The values of P and Q were 1 and 5, and you notice that the two roots that you solve using the formula for quadratic equations, for solving and finding the roots of the quadratic equations, are 1 and 5. So that is the connection. Let's now look at the third form of the quadratic function, and that is known as the vertex form of the quadratic function. Essentially, what we're trying to do in the vertex form of the quadratic equation is to make use of the information about the vertex of a parabola. Now, every parabola has a vertex. It's either the lowest point or the highest point if it's a downward opening parabola. Now, in this case, if you look at this one, the vertex of this parabola is where I'm hovering the mouse. That is the point 3, minus 4. let's try to understand what that means through an equation. So the equation for a vertex form is given by a times x minus h the whole square plus k. I'm going to add the sliders for h and k. And you'll notice that I now have a parabola that's here. And you'll notice that the vertex of this parabola is at the point 1, 1. Let me change this and show you what happens. I'm going to make the value of h as 3. Notice what happened. The parabola is now shifted from this point where the vertex was, the point was 1, 1, to now being 3, 1. So h, the value of h, represents the x coordinate of the vertex. And likewise, the value of k represents the y coordinate of the vertex. You'll see what happens when I move this to -4. So I'm going to change this to -4, and you'll see now the red line is exactly matching the blue line. I'm going to change the color of this and make it, let me make it something else like purple, right? And so you'll notice that the purple line is now exactly the same as the blue line earlier, right? So as I increase the value of k or decrease the value of k or the value of h in this case, you'll notice that the parabola is shifting either rightward or leftward when I change the value of h. And when I increase or decrease the value of k, you'll notice that it's shifting. Let me make the value of h back to 3. You'll notice that as I change the value of k, it's moving up or down. Let me show that in action to you. Look at what's happening to the parabola. As k is increasing, it's gone up, the vertex. Now as k is reducing, the vertex has gone down. So that is the effect of h and k on the parabola. So this is the connection and the relationship between the three forms of the quadratic function. We have the general form, we have the intercept form, and we have the vertex form of the quadratic function. Hope you found that informative and also enjoyable. Thank you.